Afternoon, grade 12. So yesterday we were covering terminology. Today we will cover terminology and also a naming of organic compounds. So what I did is I'm going to recap on what we were talking about yesterday. First of all, let's start with organic molecules. So what we're doing is we define organic molecules, but at testing, really you will be asked to define what organic molecules are because the definition is so broad. But basically, organic molecules are carbon atom containing molecules. They always have a carbon, and that carbon is typically bonded to other carbon atoms and hydrogen atoms. You might see, of course, oxygen are halogens there, but that's where we'll keep it for grade 12. So in order for us to define them or to name them, we have to know categories. The categories for organic molecules, we call them homologous series. For example, we have alkanes, alkynes, alkenes, haloalkanes, the ones that we were covering yesterday, which are called homologous series. Then we ask ourselves, what is a homologous series? Homologous series is a group of organic compounds that have the same functional group and general formula. Sometimes the textbook are defined by the same general formula. Now, a functional group are so a functional group, yesterday we discussed that it can be an atom, single atom, or it can be a group of atoms, or it can be a type of bond that will determine the physical and the chemical properties of an organic molecule or organic compound. That is, if it's an atom, it can be a halogen. I made examples about the halogens, which is fluorine, iodine, bromine, or chlorine. It can be even oxygen there. It doesn't have to be halogens. And then a group of atoms. Sometimes you will find that there is a hydroxyl group there, OH attached to an organic molecule. So that is what we will say a group of atoms. And I said we will add others later on, but sometimes we'll have atom looking like this, then OH like this. This is a functional group. But we'll discuss later on. This is for alcohols, this is for carboxylic acids, but thus far we will be dealing with alkanes, alkenes, alkynes. And then if it's a type of bond, that it will be a single bond between carbon atoms, or it will be a double bond between carbon atoms, or it will be a triple bond between the carbon atoms. It's going to change the physical and the chemical properties of that molecule, in i.e. color, boiling point, vapor pressure, density, and many other chemical and physical properties. Now, if ever you can understand the functional group, if ever une plant cell, a plant cell is a cell wall. So the cell wall functionally it's going to function as that cell will function as as a plant cell. Also vacuole, chlorophyll, it belong under la cell, it belong under a plant cell. However, if there is no plant, there is no cell wall piana, and the organelles of that belong to animal cell, now it cannot be defined as a plant cell, because when you find out as well as chlorophyll and so on and forth, but and teach life science up just here. So if ever une fluorine, that will make you ube haloalkane. If ever une double bond, that will make you alkane. But we will explain underneath. So now that is where the alkanes, alkenes, alkynes, they are defined as hydrocarbons. Why? Because you only find carbon atoms and hydrogen atoms only. Then now let's look at before we tackle saturated no unsaturated. Let's just look at this table so that I can make examples about what I just said. So basically, upper the table we have homologous series zethu. So I'm going to fill out homologous series zethu that we'll be dealing with. So these are alkanes. Khumbula kuthiwani apha kuthiwa hydrocarbons. So hydrocarbons, alkanes only, alkenes, and also alkynes. So those are your hydrocarbons. Why? Because all of those three homologous series, they only contain C atoms and H atoms, i.e. Carbon atoms and hydrogen atoms. And then now the fourth one, which was group still thus far, it was haloalkanes. I'm just going to use a different color. It was haloalkanes, or sometimes it's busy alkyl halides. Yeah, haloalkanes or alkyl halides. So they are a different category of a homologous series. So now let's start with the hydrocarbons. If ever you have hydrocarbons, they are going to have different functional groups. Alkanes don't have the same functional group as alkenes or alkynes. Why? Because if you remember, a functional group, it can be an atom, it can be a group of atoms, or a type of bond. So let's start with the type of bond. Start up with type of bond. If ever you have single bond between carbon atoms zako, let me just draw it this way. If there are single bond between carbon atoms, now that's going to make you alkanes. If ever there is a double bond between carbon atoms, that's going to make you an alkene. If ever there is a triple, somewhere in the chain, a triple bond between carbon atom, that's going to make you an alkyne. Yeah? However, now when we come to a haloalkane, we merely, there will be single bond because it's haloalkane. So there will be single bonds between carbon atoms. However, there will be somewhere in the chain, there will be a halogen. I'm going to use X because the halogen does not necessarily have to be chlorine. I said it can be chlorine, it can be iodine, it can be bromine, or it can be fluorine. So that X, those are halogens. No? And then now look at the structure, by the way, to emphasize the part. If ever I'm drawing a structure of a functional group, I will never put the hydrogens, because the minute I put hydrogens here, if ever I put hydrogens here, immediately, that's not a general structure of a functional group of alkanes. That is an ethane. This is a specific organic molecule. So I remove those hydrogens whenever I'm told to draw a structure of a functional group. If ever you are drawing a structure of a functional group, you do not put hydrogens. Don't put hydrogens there. And then now, let's get back to the general formula. Remember, they must, if you belong in the same homologous series, you must have the same functional group, but also the same general formula. So what that basically means is, now let's tackle the general formula. So the general formula for alkanes, it will be CN, if you remember, H2N plus 2. And then the suffix, because the alkane, look at the word alkane, it ends with the word ane, A-N-E. So all alkanes end with A-N-E. And then if ever you are, by the way, as bonds, do not necessarily have to be here. You can even do this. It's fine. Anyhow, If ever you are dealing with an alkene, the general formula is going to be CnH2n. If you are qaphela as space Z2 bezohlala hydrogen ezi2 zimkile, so lo plus 2 asemfakeli phaya, hence in CnH2n. Yeah, but you don't have to. Anyhow, because the word alkene ends with ene, that means it will be an alkene, ene. And then alkyne, if you are guessing now, minus 2 spots again, there's a hydrogen. So it's about CnH2n minus 2. You merely have to memorize as general formula. You don't have to derive them. And then the word alkyne, if you look at it, it ends with YNE. So YNE is about ine. And then haloalkanes. Basically, there's no rule up about end with what, but most of the time they end with ANE because we'll be dealing with an haloalkane that is no double bonds, but we can be dealing with one that has double bond. If we need double bonds, I end up with ENE. However, now the general formula is going to be CnH2n plus 1 and then X. X la hydrogen is a bit replaced by a halogen. So it's the halogen, as I have said, the halogen. And then now before we discuss or make examples, let's get back to the formula. Yesterday, Bente, I will remind you about the specific formula that we use. But for today's purposes, I just want to focus on structural formula and molecular formula. If we read definition, Payana, it is structural formula is a chemical formula that shows which atoms are attached to which. If you remember yesterday, I said which atoms are bonded to which. You can just use whatever English you want, but here is it according to exam guideline here too. And also, if you look at molecular formula, it says chemical formula that indicates the type of atom and the correct number of each atom in a molecule. If you remember, we would say hydrogen sulfate or sulfuric acid is H2SO4. So this is the molecular formula for sulfuric acid, and it tells us the type of atoms that are present in sulfuric acids, which are hydrogen, sulfur, and oxygen. And it tells us how many the exact number of atoms present in the molecule, which is in this case is 2 hydrogen atoms, 1 sulfur atom, and 4 hydrogen atoms. So now, however, we will be dealing with organic molecules, and general formula will guide us. So here is an example that we were given by Mr. Hlangu. If you look at this, upper structural formula. If you look at this is a structural formula, and this structural formula said we look at it and we ask ourselves, which homologous series does this molecule belong to? What is that? What's going to tell us that it is the functional group, people? The functional group of this molecule is the single bond between the C atoms. And here, there are no other atoms present other than hydrogen, which means this is a hydrocarbon. So we go to hydrocarbon. Hydrocarbon. Which type of hydrocarbon is this? It has to be an alkane. Why is it alkane? Because there are single bonds between carbon atoms. So alkane. And then I discussed with you, people, a prefix, if you remember. If there's 1 carbon, 1 meth, if there's 2 earth, 3 prop, 4 but, 5 pent, you have to learn this up to 8 maximum. But I know I got up to 10, but apparently we have to go to up to 8 Tina. So minus 2. And then if we go back there, we check how many carbons are there. The number of carbons that are there is 2, people. So it has to be ethane. Then indoni lena ibelonga under alkane, therefore ethane. So ethane, that's how we would name it. And then if we look at condensed structural formula, if you look at the molecular formula, we will derive it from a general formula because it is CN for alkanes, H2N plus 2. So we would say N stands for the total number of carbons present in the molecule. So it will be C8H2 times 8 plus 2. So that will be, C2H2 times 2 plus 2. So that's going to be C2H. Then 2 times 2 is 4. 4 plus 2 is it's 6. So hence C2H6, because we are getting it from the general formula. So that's the example there. Then now that's how you use in naming. That's how you name. That's how you determine a molecular formula and structural formula. So the prefix are very important. So now I said today in the example about the alkenes, alkenes. Yeah, and then also sense nange halo alkane. Yeah, so let's try examples zalapha. So if ever siyajonga apha, these are the naming rules. Now you can pause if ever you are going to struggle a bit. Yeah, so basically these are the naming rules. IUPAC name, IUPAC naming. I for international, U union of pure and applied chemistry. Just know that it's the nomenclature rules that we use. So basically, very important. Find the functional group. Remembering that a functional group is it can be a special atom present in the molecule, halogen, oxygen, or a combination, a group of atoms. A group of atoms can be OH or COOH, but we'll deal with those later on. Or find a type of bond. Type of bond, single bond between carbon atoms, or double bond between carbon atoms, or triple bond between carbon atoms. And then now the parent chain. It number the C atoms in this chain. So you will prioritize a functional group or number. And then if ever a functional group is a leftmost side, you start with the left. If ever it's a rightmost side, you start a right. So let me go with you as essential. Let me just give you example. I don't have space here. Okay, let me try here. 1, 2, 3, 4, 5. 5, yes. Okay. Okay, if you look at the molecule, once you put a double bond, people, make sure that the carbon where the double bonds are, the double bond is a stable octet structure. In other words, there must be 4 bonds around the carbon. Nas 1, 2, 3, 4 for lena. Even for lena 1, 2, 3, 4. So you can't put bonds. You can't make bonds be more than 4 around any carbon. But they can't be more than 4 because ukhumbule sisazoba structures they have to have a stable octet structure. So they can't be having more than, you can't be doing this. For example, this is an error because now you are saying these 2 carbons zona, they are surrounded in their outermost energy level by not 8 electrons, rather 10 valence electrons. So that's why we cannot do that. Skip is going to, it takes practice. Yeah? Number one. Number two, you look at this. It doesn't matter that the other carbon atoms zinandoni zine single bonds between them. But what matters, what's going to define this category under which this molecule belongs to, is this double bond. It's the one that defines it. It supersedes all other single bonds there. Wasn't happy. So because this molecule has a single double bond, just have to have a single, it does not necessarily have to be two. It belongs under alkenes. Why? Because there's a double bond there. There's a double bond. Kumbula, you can go and read the rules when I'm just guiding you generalizing. So one double bond means alkene. Yeah? Number one. Number two, basic, I'm summarizing what was written there. Utwapayana, I can go there with bonus. Utwapaya, priority number one, fundipa. The smallest number on the functional group. Exactly, smallest. In other words, when you count the carbons, count such that the carbon that contains the functional group, it has the smallest number. In other words, I cannot say carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, because the first carbon to contain that double bond, it's carbon 4. However, if I start on the right hand side, I will say carbon 1. There it is. The first carbon to contain that double bond is carbon 1. So I'm going to count to this side from right to the left. So I'm going to say carbon 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then now, it priority to smallest number on the side chain. Let's pause the side chains. We will get back to them. Third priority, smallest number on side chain, first alphabetically. Pause. Let's just look at priority 1. Now, call the party the parent chain. The parent chain, or sometimes the main continuous chain. So there are no branches. As the side chain passes into the branches, we will focus on them. But the branches, into branch, so it's almost like methane ingaphelelanga. Hence xa bebiza bathi methyl lento, because akukho nto apha. So singayithatha le nto siyijingisa somewhere. Let me show you ibiza kwenzeka kanjani lento. So ibiza kwenzeka kanje babe sifuna ibe ibiza kubekwa up le ndawo yabo. So replace sort of like replace la hydrogen iphaya yabo. So ibekwe pha umzekelo. But there's no need to do that. So bingazubakho le hydrogen, then yona iyohlala, okay, sendiyinantsikile, iyohlala pha like so, hlale up le ndawo yabo. But we will not be doing that, Tina. We will not be doing that. We will just be focusing on the alkene without side chain. So now, because a parent chain yetu ina 5 carbons, but still 5 ngibani spinach strong up. 5 carbons gives us pent. So it means that when I name, I'm going to say pent. And then in the teeny, pent. Now, because if you have this double bond could have been here, or it could have been here, because it can have a potential position here anyway. I have to mention its position now. When I mention its position, I mention the first carbon to contain that double bond. I can't say carbon 2, because the first carbon to contain that double bond happens in this case to be the first one that I counted to carbon 1. So this is pent 1 in. So here's another example. C, 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 C. If I put the double bond here, 4 bonds around each carbon. So I cannot put bonds here. I cannot put bonds here. So because ndenze kanje, it means ngoku if you look at my double bond isesiphakathini, it doesn't matter uba ndithe 1 2 3 4 or ndithe 1 2 3 4. Why? Because the first carbon to contain that double bond is always going to be carbon 2, the first one. So xa ndisuka ngapha ndisiya ngapha carbon 2, xa ndisuka ngapha ndisiya ngapha carbon 2 bandiqale ngapha numberisha, but if I start this side to number. So if I name this again, I will look at the total number of carbons present in the main parent chain. It's 4, so it's going to be bute. Where is that double bond? Bute 2 in. However, if people, if I had this molecule or this molecule, if I had these two molecules, yeah, khumbule 4 bonds around the carbon, 4 bonds around the carbon. Again, you cannot put bonds there. If you look at these two molecules, there is no other way that I can draw them. For example, let's just look at this one now. That double bond can only be there, people. I can't put it between the hydrogen and the carbon. It can only be there. Because of that, it will always be obvious a position here. So I can't say upper F1 in, because the obvious la position. So I just say ethene. Because of the carbon 1 in a double bond. Even to this one, if I erase and put it realize that, it's still 1 2 3. Even if I put it to the other side, see, if I put it to the other side, still 1 2 3. So it's already attached to first carbon double bond yalapha. Because it's always attached to carbon 1 double bond yalapha, it means that lendo nayo masibize propene. So people, to summarize lena na le ezi2 zona qha, in fact ethene lena propene. Then the others, there are multiple positions to which the double bond can be contained. Apha umzekelo ingakwazi ukhala carbon 2, ingakwazi ukhala carbon 1 kwi bute 2 in. Apha kwi pentene ingakwazi ukhala carbon 1, ingakwazi ukhala carbon 2. So I cannot just say pentene. What if it be pen 2 in umzekelo? So that's the case there. I am going to end this here because I see it's cool. But before that, I'm reminded, I said I will come back to these definitions, these two definitions. So now you ask yourself, what is a saturated molecule? If I come here, up hydrocarbons, what do you call it? Alkanes are said to be saturated. Why? Because if you look at the alkenes, they have a single bond. For example, if in a triple bond, you can add hydrogen, alkene. If in a double bond, you can add hydrogens, alkane. But from here, you can't now erase that single bond and make it something else. Because of that, it's saturated. Hydrogens hydrogens. It's like a sponge. If you put a sponge in, and then it absorbs all the water, that sponge is said to be saturated. If it's dry, it means that the sponge is unsaturated. So basically, in organic chemistry, it means it contains a single bonds between carbon atoms. Then if it has a double bond or a triple bond, we say it's unsaturated. So it contains double or 3 triple bond between carbon atoms. Oh, I thought that's what 15 minutes. Okay, let me just continue. I'll add in so these are alkenes, people. So basically, alkenes, they are said to be unsaturated. Why? Because there's still spaces here in which if you break that double bond, you can add hydrogens. That's why. And also, why is it that alkane in a single bond, remember this is an alkane if you remember, it's because now you cannot break that double bond and add any hydrogens because each carbon there has a stable octet structure. It is surrounded by 8 valence electrons. So because there's time, let me add other examples of alkenes. Alkynes. Now we say alkynes. What is the name of their functional group? It is the triple bond. It is the triple bond or bonds. So again, let's try an example. For obvious reasons, it has to have a minimum of 2 carbons in order to qualify as an alkyne. Why? Because if you have a double bond between, means to say triple bond, at least one triple bond between carbon atoms. So by that definition, this is an alkyne. Notice, again, rule of thumb, always you must have 4 bonds around each carbon atom. The carbon is surrounded by 4 bonds, which each represent 2 electrons, which equal to 8 valence electrons. Again, also surrounded by 4 bonds, which equal to 8 valence electrons. So, yeah. Then, the name. Again, U2. U2 is stated on earth. Yeah? So, the parent chain, Kamala is going to be earth. But because that triple bond cannot be contained anywhere else in the parent chain other than there in that position, it means that China 2 people, China 2 or China 3, you don't have to mention a carbon in a position of a triple or a double bond because it will always be at carbon 1. So this is an E. Remember, E suffix yazo ein. Remember, ein, not ion, no, ein. So it's going to be ein. This is ethine. Then let's make it interesting. C, example 2, C, yeah. Anyhow, let's put a stable octet structure. Ukumbule, this is a hydrocarbon. Remember that. Why? Because it only contains hydrogen and carbon atoms. Anyhow, now skipper up. Why is skipper up now? Because 1, 2, 3, 4 for le, and also 1, 2, 3, 4 for le. Yeah. So you always want in their time hydrogens in the two must far away and all that. You have to follow the rules. So we only put hydrogens here. So this is how you correctly draw this molecule. And now, if you remember, priority one is very important. The functional group must be at the smallest number. Yeah? Very important, smallest number all the time. So you go back. I'm the right-handed, in the turn left, and the left-handed, the turn right. You have to follow the rules. So we go to the first carbon. In which side is the first carbon closest to the triple bond located at? And if we check it's located closest to the right. So I'm going to say 1, 2, 3, 4, 5. Again, people, notice I'm not saying starting from this side 1, 2, 3, 4, 5. Look at Cascale left, carbon 3 or contain that triple bond. But if ever right, it's going to be carbon 2 to contain that triple bond. So rule says my functional group must be contained at the lowest carbon possible in the chain. So now it is at carbon 2. Remember, we don't mention a position only when the double or the triple bond is at carbon, is only when the molecule has 2 or 3 carbons. Only time we add or only time we prop. Ne? But now this one has 5 carbons, so 5 people will pent. Ne? So it's going to be pent. Ne? Now notice, and as I always leave the position there to mention. However, now the first carbon, from right to left, the first carbon to contain that double bond, yes, why it's between 2, ne? But the first one is carbon 2. So we'll say pent 2 in. Pent 2 in. Yeah? Spent 2 in. I can just do one example. C21, 2, 3, 4, 5, 6. And then where do I put the, let me just put it here. Again, you just need to be careful about your octet structure. Ne? So I will just say upper because I see it's safe. And then when I get here, I have to check now. 1, 2, 3, 4. That means I don't put any hydrogens here. 1, 2, 3, 4. I don't put hydrogens here. So I start here putting hydrogens. Yeah. Remembering that this is the structural formula, people. Structural formula. So if you look at this molecule, it has 6 carbons. However, also second thing about this formula, it's symmetrical. People, how to symmetrical? It means left hand side, right hand side. In other words, even if I count starting from the right hand side, even if I count starting from the left hand side, the carbon, that first carbon that contains the double bond should be the same. It should be the same number. So now let's land on it. 1, 2, 3, 4, 5, 6. So if you look at when I start from the left hand side, the first carbon to contain that double bond is carbon 3. And if I start from the right, that's 1, 2, 3, 4, 5, 6. If I start from the right hand side, again still carbon 3. So it does not matter where I start, the same results I'm going to get. So this is going to be, I check the number of carbon, total number of carbons present in the chain. These 6 people, ne? So manu hex. Where is the double bonded carbon 3? Hex 3 in. So in doni kamalano, the hex 3 in. Yeah. Also, one thing that I have omitted. Let's start here. By the way, I have omitted the general formula. People, CnH2n. So often senze ngokuzawuthetha ofuna ukumamele. Remember, it pent 1 in. Pent 1 in injani? It has 5 carbons, ne? So it's about C5 people. H 2 times 5. So ngubani? C5 H 2 times 5 10. C5 H10. But 2 in. Ngubani? C4 but khumbule 4. H bani 4 times 2. 4 times 2 is 8. Ethene bani C2H4, and you can go and check in the molecule above. You will get the same results. So lena ngibani ingu C3H6. Should follow the general formula. Remember, these are molecular formula. Emphasize the part ne. Ezi in brackets are molecular formula. Lena is general formula. All of these molecules are defined by the same general formula, and all of them, they have the same functional group. Hence, they belong under the same homologous series. They are alkenes because of that. Akuthiwa ziyafana nqwa, but zonke zine double bond, at least one double bond, and also all of them have the same general formula, because you can just apply general formula and be able to obtain or get the molecular formula. And then we come to this one, the alkenes, general formula is CnH2n minus 2. It's going to be a little bit challenging to do in mental maths, but case I'm a grade 12. So, apa is about ethene is about C2, ne? C2. And then we say 2 times 2. 2 times 2 bani? 4. 4 minus 2 bani? 2. So CH2. And if you look at the structural formula, remember, structural formula ndabantu ndoni lena molecular formula, ndoni lena general formula. Yeah? Be able to distinguish between those and be able to define them. So if you look at them, there are 2 carbon atoms here and 2 hydrogen atoms. Size kwi pent, mhlawumbe upent a bit challenging. C pent C5. H bani 2 times 5 10. 10 minus 2 it is 8. Yebo. You can again molecular formula, structural formula, ndoni general formula. Same general formula, same functional group. We do also hex. Hex is supposed to be C6. H 6 times 2 is 12. 12 minus 2 is 10. So C6H10. You can even, if ever your molecule is way too long, just count, do a count if you want to verify. We already counted the carbons here, there are 6. So that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C6H10. If ever you are wicked, like we are liberally general formula, you can even do that. Just count, do a count, visual count. 8 minutes. I'm just going 8 minutes. I'm going to do 2 alkanes. Ne? I mean haloalkanes. Haloalkanes, because I see class as senalo. Haloalkanes. What is their general formula, Kanin? I mean their functional group, obviously, it's a what? Halogen. And then what was their general formula? It's CnH2n plus 1x. Let's try the simplest. The simplest haloalkane that I know of has 1 carbon. X way to sit in Br and then I'll do it side by side with another sitting. Let's just use UPR nalapha to emphasize something ebalulekileyo. Then the last one, I'll just use 4 carbons. Okay, let's just use OPR, no F, so that we will emphasize the rules. Okay, let's start with example 1. So, if you remember, because the haloalkane normally they end up with A and E. Now, we have to check which type of halogen is present. It's a bromine. Now, let me put it here. UBr in bromine. So we start with bromo. Yeah, vamos. Then if we chlorine is about chlorine. ro. If the iodine, iodo. If if it's a fluorine, is by fluoro, ne? Fluoro, ne? Those are the abbreviations that we're going to use. We're not going to use the total name, fluorine. So let's go back to the rules. Rules, again, kumbula, priority number 1, the smallest number on functional group. Now I happen to have 1 carbon per. I feel like it's going to be, yeah, I can see, I don't have to emphasize that rule thus far. So let's look at this molecule. Then we'll see, BR. So we'll say, Payana, we'll see carbon A1 bani. Meth. So it's about meth. You a yellow alkane, so methane. However, now this molecule has a bromine. Ne? And because the carbon E1 up, it will always be at carbon 1. Even if it was here, even if that bromine was here, still carbon 1. Even if it was here, still carbon 1. So point being that it has carbon 1, so we don't have to mention its position. So it's going to be a bromo. So the name now, the halogen, it becomes the prefix now, the new prefix of the molecule, bromomethane, people. Yeah? But however, if we check the second one, the bromine now, if you count from this side, 1, 2, 3. Even if you count from the other side, it's going to be 1, 2, 3. In other words, the bromine is at carbon 2, people. Why? Because potentially, if it was here, it would be at carbon 1. So now it happens to be at carbon 2. Carbon 2. So we have to mention that position. So this is going to be 2 bromo. And then we look at the parent chain, people, ne? Okay, the main continuous chain. The main continuous chain contains how many carbons? 3. Some come with 3. 3 for prop. So it's about pro. So it's about 2 bromo propane because it's haloalkane. So it's a tribelango A. 2 bromo propane, people. And then we come to this one. Now we happen to have 2 substituents or halogens. Yeah? Let me add the word substituent so that I forgot to add it. I think I still do have it. Let me look it for it. I think it's this one. No. It's not this one. Okay, yeah, it's it. Substituent. Substituent, because I just used the word. A substituent is an atom or group of atoms bonded to a carbon chain. So it's a group of atoms, in this case Z2, Z group, they are bonded to a carbon chain. Yeah? And this can be an inorganic atom, halogen. Can be it does not necessarily have to be an organic one, or an alkyl group. An alkyl group. Remember, alkyl group, we'll talk about it. I just want to focus on the particular alkyl group probably tomorrow. But yeah, emphasis. Alkyl group will be discussed tomorrow. Anyhow, so here, these are my substituents. The substituents, we treat it the same as, let's go to rules. Of Nasiego rules now. In fact, let me just first change the chain here so that I make things easy for myself to emphasize all the rules involved there. Yeah. Okay. Rules. Now, first priority, some apply again. A functional group must always be at the smallest number, but also now, if ever, it's in a side chain, Side chain, it can be a substituent side chain. I treat it the same because we treat them the same when we number. So what's going to happen now is they must have the smallest first side chain on the first side chain. So you can even payana fagela brackets with the substituent, because now you apply the same rule. Smallest number, now you occupy the smallest number. Yeah. And then smallest number on the side chain, first alphabetically. First chain, on side chain, first alphabetically. So if we go here, strong apart on that chain, where is it now? If you look at this molecule, when we start upper left, 1, 2, 3, 4, 5. And if we start at the right, 1, 2, 3, 4, 5. The first substituent to occupy the lowest number, left, see right, is at carbon 3. Carbon 3. However, if we start from the right, it's at carbon 2. Yeah? Carbon 2. So now we will prioritize the left-hand side because the first substituent is on the left-hand side. So qala ngapha left kweliqala ngapha. So qala ngapha sibalayo. Singapha because uBR closer people xa ngiqale right than xa ngibala left. Zigcwele ngapha, zigcwele kwelicala, basically zigcwele kwelicala. Substituents azigcwelanga ngapha kwelicala. Yebo, uF yedwa close kwelicala. That's what I'm saying. So I'll start from this side. This is my carbon 1, 2, 3, 4, 5. Yeah. And then when I write the name, now obviously it's about pentlo because there are 5 carbons there. So pentlo, pentane, because they are single bonds between carbon atoms. However, BR and F, now we are going to BR bromo, F fluoro, bromo lo. Fluoro. So Thomas alphabetically when we are naming, that means that if we position ka BR. If position ka BR is number 2, so I am going to say 2 bromo. Ndizenge position ka fluoro, 3 fluoro pent, remember main continuous chain, pentane. So then I 2 bromo 3 fluoro pentane. Yeah, it's iba complicated kancinci ke ngoku ifika apha, but I want to challenge you because ixesha seliphelile. I'm going to make more examples tomorrow, then we tackle other substituent, which is the alkyl group. However, let's just do a molecular formula. Most of the time, molecular formula, or you will never be asked Kazi 2 substituents. You will only be asked Kazi when you're having one substituent most of the time. So this one is going to be C. Kumbula sa apply la rule ka N carbon 1. C H 2 times 1 2 plus 1 3. CH3 doni Br. So ngu CH3Br because ni carbon 1 hydrogen Z3 uBr1. And then we come to this one. Dilambani ngu C3H bangapi? We ask ourselves, so 2 times 3 bengu 6, then plus 1 7, so H7 bengu Br. If bengu I bezot I bengu FF, so CH3H7Br. So this is 2-bromopropane. Yeah, that's it. Again, the molecular formula is we got it from the general formula, but it corresponds because there's 1, 2, 3, 4, 5, 6, 7 hydrogens. And then they are defined by the same general formula and what? Functional group. Zonke, all these 3 molecules, they have the same, they belong under the same homologous series. Again, if I will naming, I'll start with it, start a substituent, and then we get deep into it. But at the very least, you should go back and listen to the part for alkenes, the alkynes, because that's where I wanted to end the lesson. Anyhow, this is the end of the lesson now.